Alright guys, welcome back to the channel. It's been a while since I've done another Terminator X video, but I kind of want to do a follow-up of the boost control that I talked about a while back. I think the video was labeled Yet Another Holley Boost Control, and I gotta say guys, I'm really loving this boost control. It takes a little bit more time to set up than some, but it's simple, but it's a little bit time consuming to set it up. I'll show you guys how I did it. If you go back and watch that video, I explained it in there, but I'll just go over it rather quickly here. Basically what we're going to do is we're going to use a new output. We're going to make a new output. We're going to call it Wastegate Plus. That's what I call it, or you can just call it Wastegate. It's pulse width modulation. If you're using a MAC valve, this system works with a single MAC valve feeding the top of the wastegate. The bottom of the wastegate will be referenced to the turbo. That's how I've got it hooked up, and it works great. You'll enable it, configure it, and then of course after you enable it you can go back into your pin map and set it in which pin you want. Basically what I did, I don't have a switched input, but I do have a sensor input. This output will activate when boost is above 2 psi, so that way it's not sitting there trying to do stuff with that MAC solenoid when you're in vacuum cruising around, and deactivate below 1 psi basically. And this is boost psi, so that would be above your ambient pressure outside. Linked outputs, none, no timer, and then we'll go to the pulse width modulation setup. So I use fixed and roughly 18 or 20 frequency. I use 18, seems to be working fine. Haven't tried a different one, but if I change it now, then this map would be all out of whack. So what you'll do is you'll set your duty cycle or your table unit as duty cycle percentage. Since we're using a MAC solenoid, we're going to use it with percentage. And then x-axis right here is boost psi. So this is the actual boost pressure that your intake manifold is seeing. And then you'll have your target boost on the left side going up and down here. And so what you'll do is, I do 0 to 30 pounds because I run up to 24, 25, 26 pounds if I'm really pushing it. So it works pretty good to just do every 2 pounds of boost. And then the same way here, you want these two to match. So 30 by 30 up here would be 100%. 28 by 28 is also 100. 26 by 26 I got 80. 24 by 24 I got 70. And then 66, 61, 58, and so on. So the way this works, let's say if you're commanding, let's just say for instance 20 pounds of boost. That's your target boost level. If your boost is at 0 pounds of boost, the duty cycle will be 100%. If it's at 2, 4, 6, 8, 10, 12, 14, 16, still at 100%. Once we get to 18 pounds, it starts to drop the duty cycle. And by 20 pounds, it drops it down to 61%. And the way I come up with these numbers, so where they match, so 22 by 22 is 66%, right? The way I come up with that is doing testing. So this is where it takes a little bit of time. It's simple, but it takes a little bit of time to set up. So what you'll do is you'll go out and just fill this whole map with 66% or 60%. I just, for a rough idea, put in 60%, go drive it, see how much boost it makes. Do it again at 70%, do it again at 50%, at 30%, so on, and then write down those boost numbers that it runs. Then you'll come in here and you'll fill these blocks in with those boost numbers, or with those duty cycle numbers to match those boost numbers. Fill in all the blocks in between. So let's just say if you did one at 16 pounds and it was 55%, and you did one at 12 pounds and it was 50%, well then you know it's roughly 59.2% in between there. So you can type that one in. So you don't have to do every boost level. Heck, you could probably get away with doing 2 of them. Do one at 10 pounds, run at 30% duty cycle and again at 24% duty cycle and see what it runs. Then you can fill it all in between. And the reason I don't run 100 all the way up to that block is to reduce overshoot and to keep the boost level from surging up and down. When I first did this map, that's what I did. I only used a single row of numbers here. I would run 100 up to this number, like let's just say at 24 pounds and run 70%. So I would have 100 here and 0 here. Well, I would run into this issue where the boost would go up and down, up and down. You can feel it surging. So by smoothing this out a little bit in between, or with the cells next to it, it smoothed it out, and now it's perfectly smooth, and it works awesome. So I'll go over a data log to show you guys just how well it actually did work. Open data log. Oh, actually, before we go to the data log, let me explain where we're getting this target boost number from. Target boost I'm actually getting from the boost ICF. So you'll still run this. You'll set, it doesn't really matter how you set any of this up because you're not using the dome control setup. You're not using this. You're not using this. Solenoid configuration, control method. You're not, well, yeah, we only have that selection in Terminator, but operating mode, that you do use. So I'm doing boost versus RPM. So if you look under boost versus RPM, I have 4 gears, TCU input for shift recognition, and my curve is 13 pounds every gear at all RPMs, excuse me. So basically that is how I have it set up on mine. Of course, you can go in here and totally customize this. So you got your first gear, you can type in whatever you want, and this calculates over the same as boost pressure. I know this number is supposed to be dome pressure, but it works as boost pressure. I don't know why, but it does. Or target boost, for instance. And so then you would go over to boost setup. You also have your boost scramble. You can use that too. So remember, I had 13 in there, and then the amount to apply with the scramble is 11, gives us a total of 24 pounds of boost. And then I have my launch target at 14 pounds of boost. All of that stuff works, including the safety setup, not the revert to wastegate. That does not work because we're not using the Holley's wastegate control. We're using a custom one, right? So you would still set that to cut ignition is what you would do with that one. I don't know why I had it that way. I think I was going to try it either way. I never went that high, so this boost control is so good it never over boosts. Of course, things can still go wrong, so that's where the boost cut comes in handy, or the boost safety comes in handy. All right, so we'll open up the data log and I'll show you exactly what was going on here on my 961 at 142 run. We'll zoom into the run itself. And here you can see what is going on here. Let me turn off this ignition timing line here so we can see a little bit better. So as you can tell, my launch boost, target boost was 14, actual was 13. Now, why did those two not match up? There's a couple of variables here. It's not just that I'm off on the map, because I know for a fact that 14 pounds of boost down track, I need 60% duty cycle. However, when I'm commanding 14 pounds of boost, or when I'm spooling, 60% will only give me 13. And that's an error that you can't make up for with this type of setup. I mean, you could, but you run into the issue where it'll overcorrect again. Let me show you here on this once again. Pulse width modulation. So I was commanding 14 pounds, so it wanted to run at, I was commanding 52, or it would want to run 52%, but 52% wasn't giving me 14 pounds of boost. So it was actually giving me less. So because it was giving me less, this 70% was adding back in, and it ended up in between there, if that makes any sense. Because if I'm commanding 14, I have it set at 52.9%. I know for a fact going down track, 52.9% gets me 14 pounds of boost. But because of the staging, it just doesn't work because of the way I do the staging. I have the staging as a timing setup, not as a two-step limiter. This is my launch boost. I have a 1D table set up, timing offset versus RPM, switched enable, trans brake enabled. And then I have basically the RPM down here, 32.5 RPM or 3250 up to 4,000. And what happens is as the engine RPM wants to rev up and up and up, it pulls more and more timing, all the way to the point that the engine won't rev any higher, right? So according to your load, if you got a tight converter and it puts lots of load on there, you only need to pull like 15 degrees of timing out, and then the thing isn't going to rev higher. But if you got a loose converter, it'll pull 20, 30 degrees out to keep it from revving higher. Mine happens to be about right there, so mine is launching right close to 3,500 RPM. And this works great because you pull up to the line, you hit the button, there's no popping and banging, it revs up, sounds like your foot braking it, and that's it. So I love that. But because of that, with the timing being so low, you can look at the timing. If I pull that back up, ignition timing, you can see this line is running like what, 1 degree. Let me scroll here a little bit. -3, -10, 0, 0, 1, -9, 1, 2. So the timing obviously bounces around, but if you look at the RPM, it's holding at like 3,500 RPM. And this allows a turbo to build all the boost at once. I mean, it has no problem. If I would put in the target boost 20 PSI, it'll make 20 pounds or 19 or whatever it would be. So you do have to offset a little bit for the launch. If you're doing it the way I do, where I'm not just banging off a two-step, I'm using the ignition timing, because lower ignition timing always tends to make more boost for the amount of wastegate pressure. Or it's the other way around, I'm not sure. But anyway, if we watch the launch here, what happens? My target boost is still at 14, and then the next frame over, I let go of the button. Target boost is at 24 pounds. Actual boost is at 13. What happens to the wastegate? It's now at 100%, so it's slamming that wastegate shut as hard as it can. And you'll watch the boost climb up and up and up till it gets, let's see, where does it drop? Yeah, here you can see on this red line right here, this is the wastegate duty cycle. It starts to drop as the boost is nearing its peak where we want it at 24, or nearing its target, I should say. And as it reaches its target, it finds its happy spot down here. And you can see the duty cycle, it actually does change to keep the boost pressure where it needs to be, right? You can see the duty cycle changing throughout the run. However, look at how steady that boost is. I mean, it is, if I scroll through here, it's like within a half a pound of boost. Or even tighter than that, pretty much all the way down the track. And that, my friends, is pretty awesome. That is why I really love this boost control. I know if you guys are looking at this stock 6 liter, 17.8 degrees of timing on 24 pounds, sounds insane. But what's actually going on is my reluctor is off by 3 degrees. So if you take 3 degrees off of that, I'm running like 14.8 degrees of timing. With twins, what is that, 15 and a half degrees of timing, up at 6,800 RPM. Engine seems to like it. So anyway, that's a little bit showing of how this boost control works. I gotta say, guys, it works just freaking awesome. So hopefully this video helps you guys. If you got any questions, let me know. I'll try to answer them in the comments, or I will upload another video if there's enough. I know there's some weird stuff going on in this data log, like my 1-2 shift, which happened right here. The RPM went up because I accidentally short shifted. It was at 6,300, but my converter was fixing to couple up. Instead, right before it couples, I shift, and then it just flashes at even higher because it's blowing through the converter, and then it finally couples up halfway through first gear. Hey, or halfway through second gear. Still ran a 960 on this pass, so I am very curious to see what it would do if I wouldn't short shift it. Probably get me into the 950s, and that would be pretty awesome. Maybe next track outing I will do that. But yeah, guys, if you got any questions, let me know. Thanks for watching.